Hey guys, what's going on? I'm Luke, and we're here picking back up on part 3 of building a full stack CRUD application from total scratch, right? We started with an empty directory, we built that up, we built out the server folder. I have a couple applications open, so if you're following this playlist, you probably already have all these things open, but if you're coming into this one because it's been like a week since my last one, then go ahead and get your terminal up and running, your VS Code with this project back up to start coding along again. We have our tabs set here from Postman, and like I said at the end of the last video when I decided to cut off the recording, you're gonna need to get, if you want to follow along, I mean, you're welcome to do whatever database you feel comfortable with. Like if you already are familiar with ORMs, or you like Postgres, you like Mongo, it doesn't really matter. I'll be doing MySQL because, like I've said in previous videos, this series is going to be a great follow along for you guys and gals that are trying to learn how to build full stack applications with this kind of quick tutorial I'm giving you here. But it's also meant for my graduating students that do have some SQL experience already. This is kind of helping them enhance their knowledge and things like that. So as always, if you need to pause the video now to go install MySQL, look up the MySQL community installer. Go ahead and pause the video and follow along with the instructions from whatever you're doing it on Mac or Windows. It doesn't matter. You don't even have to use MySQL Workbench if you don't want to. This is just my chosen graphical user interface, or GUI, which is written right here for us, to visualize what you're doing. If you feel comfortable using a VS Code extension or just writing commands from your terminal, go for it. But I'll be using this as, again, my students already know what it is. Now, when it comes to installing, I should have said this before I said pause the video. Most cloud instances, when you deploy online of MySQL, are still like on version 5.x or something like that. That's a very common one you're going to be seeing all of the time. So just keep that in mind as well. Like that's the one you're going to be seeing the majority of the time. So that doesn't mean that you can't install like 8.0 or something higher than that, depending on what version the latest is. Again, I think I'm like on 8.1 or 8.0. One or something like that. We'll see in just a moment. It doesn't matter because ultimately you can change some of your database settings. At the very least, you can just dump your database file and be able to modify it directly by just doing a find and replace of certain values here or there. So I've had no issues helping students deploy their old SQL databases to 8.0s and 8.0s back down to 5.x's, for example. So if you're back here and installed and ready to go, let's go ahead and dive on in. I'm not going to be coding out the entire schema for this project right now. We'll actually delve into that in a different video probably, or maybe even later in this one. I need to get a couple basic things up and running so I can begin testing my API endpoints to make sure they can run queries. And then we're going to start working our way on some of the authentication and authorization logic we're going to be using on our servers, which I'm not going to be doing anything uber complex with like refresh tokens and access tokens. Maybe that's something I can put a pin in for a later video where we begin adding more and more features to this app. Like, again, this playlist can get gnarly long, and that's kind of what I want it to be, super long, and I want it to be a great portfolio project for myself and for y'all. So yeah. Okay. You will have your local host root connection ready to go, typically on port 3306. You won't have this one here. That's my deployed database, so don't worry about that. But we have our dev database, and you may not have a bunch of random schemas like I do. And sorry, I can't really zoom in on these side panel windows here, but I did enlarge the text on the query window at the very least, so y'all can try and follow along with that and not have to squint and zoom your eyes in, right? Let's see. I am on 8.018, so I haven't updated in a bit, but I know like 8.1 and 8.2 are higher. Now, the biggest, not qualm, because I totally get it, I understand why they changed the authorization and authentication process that MySQL uses. So this is actually going to vary what's going to happen here. If you are on 5.6, you are able just to create users and use a particular library in our project, which I don't think I have it installed. Did I install? Yeah. Okay, so I installed just vanilla MySQL right here, and some of y'all might be wondering why not switch to MySQL 2. MySQL 2 is just a continuation of the MySQL library, and as well as including some native TypeScript support, which is awesome. It has a couple differences and nuances, especially in TypeScript types and whatnot, but I'm going to stick with MySQL. That's what our course takes us through. And if you're working on a 5.6, this is a perfect library for it. But maybe we'll do like a video where we'll be like, okay, well, if we need to update a library and all the fun that entails, we'll go with it. But since I installed MySQL, we're going to go with that one right there instead of MySQL 2. Now, what I'm trying to say here is if you have version, and I'm not just talking about Workbench, I'm talking about MySQL Server, because I've had students somehow misinstall mismatched versions, which I don't know how they did, but that was pretty impressive. But nevertheless, I have a Workbench of 8.0 and a MySQL Server of 8.0. That means that this particular version of MySQL is running an authentication, an authentication for how they store their passwords that the MySQL not-to library doesn't understand. So we actually have to include a clause when we end up creating our user to connect with as we go through this tutorial. If you're on even higher versions of MySQL, like I don't know what the latest one is, but I had a student recently come through that was like 8.1 or something like that, that they could not connect to the MySQL library with the new authentication standards that the newer versions of MySQL Server have. In that case, you have to use MySQL 2, and that's okay if you do. Like I said, it's pretty much the same library. There might just be some difference with the TypeScript typings. But in the interest of covering the most use cases, I think sticking to an older version for now, because again, not much really changes between these, is going to be the way to go, and to get y'all up and running with the fundamentals and understanding and moving forward from there. So as of right now, I have no schema. And I think at the beginning of my series, I mentioned that you don't need to know a ton about MySQL, as I'll try and keep it simple and go through it. A schema is going to be your collection of tables in a MySQL database. That's all it is. It's going to be the name of basically your collection of data, however you want to organize it and whatever you want to call it. So we're going to call ours. And my students always ask, do I need to do capital casing like this for SQL statements? And the answer is no, you don't. Typically, it's only done because it's a great way of visually identifying SQL written code versus something like a column or table name, for example. So yeah, if you want to create a new schema, it's actually rather simple. We write the command create schema. We're going to call it DnD _ note taker, like so. And all SQL statements have to end in if you're using point and click in the GUI, I can highlight this command and click to run it. But if you want to use the shortcut, which is Control Enter on Windows and Command Enter on Mac, then be cognizant of placing your semicolons. This will also be a good habit to have if you're using the VS Code extension, or if you're writing commands in your terminal, you need to make sure those semicolons are there. But if you're writing commands in your terminal and you feel comfortable doing that, then I'm sure you know that. But yeah, here we go. We're going to go ahead and create our lovely little schema right here. Bada bing, bada boom. We got the green check mark down in the workbench, which means the command has ran successfully. It says 1 row is affected. It's not going to appear in this list right here until I refresh. There it is, DnD note takers in the list. Now, we're not actually, any other commands we write right now are not going to be done to our newly created schema because it's not yet quote unquote selected, right? So what we need to do is write another command, use DnD _ the same name of the schema we just created. You can also just simply double click it right here in the GUI window. But like I said, I want to teach you all some basic commands. So voila, we have made our new schema, our project, and we have now, we're now using it. So the next set of commands we have will actually be done to this particular schema, meaning we're going to starting to create our tables. So there's two primary tables I think we're going to need to have to care about, which will be our users table. And I know this is currently incorrect syntax because I haven't actually filled out what these are going to be, but I just wanted to point out that these are going to be the first two tables we're probably going to be worried about. I want a users table because I do want individuals to be able to register and log in to my site, and then I also want clearly a notes table, so as users take notes about their D&D game, whatever it happens to be, that's where they're going to be stored, right? So those are going to be our two primary tables we're going to create here. And I will probably be copying and pasting this into some kind of, text file in the repository. So that way, if you mess something up or you need to drop your schema and recreate it or something like that, you'll have this available in the repository in GitHub to take a look at if you need it. Okay. So yeah, table users. We are going to need an identifying column. That's the core thing about MySQL and any relational database. You got to have a identifying column, like a unique and unique as in not repeated, It's called a primary key. It is the primary identifier of any individual row of data in this table, and they need to be unique. A lot of the times we'll just stick to something simple, such as it's a number that will auto increment over time. I personally have recently moved into more nano ID territory, but I might stick with UUIDs for this one, which are hard to visually look at and require some copying and pasting to do some selecting. But nevertheless, I think UUIDs are a great way to go and learn about how to generate unique keys and things like that. So that's what we're going to do. So we're going to be using a library called UUID in our code base here, which I don't know if I've installed or not. I haven't. Let's go ahead and install it now so we can take a look at what I mean by this. npmi UUID, and I don't know if it comes with its own TypeScript typings. It may. We'll find out. Like I said, we'll get a warning in the terminal window if it didn't. So, okay, we got it installed and good to go. I'm going to go ahead and get my project up and running for right now because we're going to need to do so. I want that Webpack output. There it is. And back over yonder, I can now head to my server TS to do some quick testing, right? I always like to remind myself that in case I leave this testing code in here to come back and delete it later. So let's go ahead and import something from UUID. There's different versions that you like different, I guess, algorithms, right? That you can import from UUID. You can actually look this up if you go to their documentation, and this is what they recommend you do, is simply importing a version 4 and you alias it from v4 to UUID v4. It's a very common import you're going to see, recommended to you by their own code. Let's console log a value here, and we're going to do a simple call to UUID v4 as a function like that, passing no additional arguments, and let's see what this console log gives us. That is right there a universally unique identifier using whatever the v4 algorithm happens to be, and that is going to be what our identifying strings are going to look like in that users notes. All of our tables that require primary identifying columns will be using this UUID right here. And if I'm not mistaken, they actually all will come out as the same length because that consistency is going to give us something we can take advantage of in MySQL. So yeah, they're all 36 characters long every single time it generates a new UUID. So what we're going to actually do is delete this testing code because I wanted to point that out just to show you what they look like and how long they were, and the fact that they were consistently 36 characters long, because that will alter what kind of column we're going to have here. We're going to call this the ID column, no surprise there. And now we have to tell MySQL what kind of column this is going to be. And my students and a lot of folks will just hit the varchar, go for it, which stands for variable character. This can be anywhere from 5 variable characters, so 0, 1, 2, 3, 4, or 5, but no more than that, right? So you're thinking, okay, well, how about a variable number of characters to, well, a length of 36, which I just console logged several times. In this case, that's not a bad idea. That will work totally fine. But the thing is that the UUIDs will never be more or less than 36. So we can actually leverage this knowledge and switch from a variable character length to a fixed character length. And when it comes to MySQL, I tell my students not to super stress right now about, again, like, unless you're going to be going into a specifically SQL profession, you probably want a more in-depth tutorial than what I'm giving you here. But this is a great foundation, great starting point, right? So I get my students thinking about allocated memory size because it takes more memory per row for MySQL to assign variable character lengths because it has to be a dynamic length of variable characters versus a fixed char length like this one, or char, char, whatever you want to call it. Whereas it knows, oh, I will always just assign this specific amount of memory for this particular column every single time. And those little like optimizations like that multiplied by 20, 30, 40 million rows of data can add up to a lot. So while early on I tell them just get working, whatever you can get working, I will typically go through their schema and give them like little bits of micro advice like this to get their brain thinking in that regard moving forward. So we're not going to highly focus on that because I don't think my test data is ever going to get to that size. Well, hopefully not. But yeah, that's something cool to point out here, that varchar, while it's like the go-to for like everything to get up and running early on as a newbie MySQL dev, I like to kind of point this out here as well as a few other things. So yeah, awesome stuff. ID char 36. It'll always be 36 characters long. And yeah, that's good. So we have to identify that this is going to be the primary key of this table. Again, like, what is the primary column that will identify each particular row. We are going to do so by writing the keywords primary key and specifying that the ID column is going to be that key. You could also just write primary key after this char36. I personally like, for some reason, I like to keep my key, like my primary and foreign keying information down at the bottom of the create table. It's just a personal preference. It doesn't really matter at the end of the day, right? And since it's going to be identified as the primary key, we don't have to write a keyword like unique or something like that because we don't have to worry about it, right? Okay, so let's say we are going to have our users register with an email and a password. So we'll do a varchar because I don't know how long their email is going to be. I think like I was taught like 250 is like a solid go-to for a lot of these things just to kind of go for, or 255 or something like that. I remember my mentor when I was a student here at Covalence just did that for all of his, and so I followed what they ended up doing, and that was like my go-to thing for pretty much everything. These days I'll apply some more thought to it and be like, I don't think there's going to be a massively long email string like that. I mean, we'd be surprised if there was. Let's just go with like, I don't know, 100 characters or something like that. I don't think they need to be any bigger than that. So, and here's the thing I'm mentioning why we have to consider how many characters there are, because I don't want to have someone be able to register luke@covalence.io 5,000 times, because that would be, well, bad. Like, no one else should be able to register my email address if I'm already registered with it. So we can actually provide a keyword to this column called unique that will make sure, and this is case insensitive, by the way, which is a very cool thing and important to know. It's case insensitive, that I want to make sure that luke@covalence.io cannot be inserted into this table more than once. I wanted to throw an error in case someone does that, and we'll have error handlers saying, hey, that email address is already registered. If you forgot your password, try this or something like that, right? Cool keyword to know. But because it's going to be unique, it has to index all of the letters in the email, and the higher your varchar count is, the more memory that takes. And on, especially like on free tier deployments, like on Heroku that uses ClearDB, they have constraints about how much memory you're allowed to use for your free tier deployments. So unless you pay for it, a lot of the times they will restrict you. So that's why I encourage y'all, if you have any kind of like keys that need to be unique and things like that, to not get overboard with how long their varchar value can be, right? So next we'll have a password column. That makes sense to me. I'm not going to mark that as unique. And honestly, we're going to be using eventually, because I'm not even going to, what's it called? I'm not even going to humor the idea of, what's it called? I'm not even going to humor the idea of inserting a plain text password into our database, even for testing purposes, like password 123. We ain't even gonna go there. We're gonna be downloading and using an algorithm called bcrypt, which is actually a very standard thing you'll see a lot across projects. We even have videos on our YouTube channel if you wanted to migrate from something like bcrypt to a different algorithm, but I like using that blowfish cipher, and we'll talk more about that when we get there, which actually might be very soon, because I want to generate a demo password to see if like the length looks the same or not, right? But something else I forgot to mention is we should probably include some additional context for these to make sure that they are not by default insertable values. So if you leave something marked as null, that means it can be inserted as a null or blank value, meaning I could register an account with no email, but that doesn't make sense. So I'm marking these as not null specifically, even though like I believe it defaults to null if you write nothing. But we're going to be trying to be fairly explicit in our code here. So I'll be writing not null on these columns to indicate to myself and future readers and watchers of this playlist that when they go through the repository and they see these create tables, they know what that means. That I've explicitly made sure that, hey, these things cannot be just, crapola. They got to be real values here, right? Okay. Before I hop back into code and talk about bcrypt a little bit, let's keep on chugging on here, right? We'll probably need a first name column of some kind like that. I don't know how long people's names are going to be. 60 seems to be my go-to right here. I will say when registering a new user, they have to provide their first name and their last name, like so. And that's really all we're going to care about. And from there, it's always good to just keep track of some metadata. Like, it's good to know when our users are registered, because when you get a big user base, you can actually do some pretty cool MySQL queries to aggregate the data and even output in a single query the most popular day of the week your users register. So maybe you can run an advertising campaign on Wednesdays to try and entice more people to register. Like, there's some really cool aggregate functions you can do in MySQL that I've had the pleasure of learning over the past year or so as I delved further and further into SQL stuff. But for now, let's go ahead and just make a created at column. Again, these are column names. They actually don't matter what you call them at the end of the day, because they're just names. Like, you can alias them to other things and you can rename them later. It doesn't really matter what they're called. Just use things that make sense. I'm a fan of lowercase snake case here, which is why I used to be using lowercase letters with underscores. Okay. Now for here, we have two choices. We can go between a date time and a timestamp column. They do have some subtle differences when it comes to, I believe, how they're retrieved into our code, whereas one might be treated as a new date object that deals with time zones and the other doesn't. I actually have a video on our YouTube channel called Node MySQL Time Zones. Go look that up if you want a more in-depth explanation of the extreme differences between these two. But at a fundamental level, they store the same information: month, day, year, hour, minute, second, and I think millisecond of when something is created or inserted into the users table. So this would keep track of when a user registers their account to the T, right? Now, the big difference between these two in terms of MySQL efficiency is that date times can be anywhere from the year, I think, like 1, if I'm not mistaken, maybe year 0 or 1000, all the way up to the year 9999. So that's what's good about date time columns. They're great for birthdays where your users might be born in, say, 1970s or something like that. I don't think you're going to have like any boomer or Gen X users coming in here and registering to this DnD note taker. I mean, I could be wrong about that. But yeah, date times are meant to encompass a long range of potential dates. Yeah, so it is literally the year. Oh, it's the year 1000, it looks like. Yeah. So I had to Google up my other monitor. Yeah, so 1000 to 9999. So, you know, by the time we get to the year 9999, none of us will be here, barring some, I don't know, crazy invention in the future. But yeah, that's what's good about date times. And then timestamps have a smaller range in MySQL. Specifically, they go from, hold on, I want to make sure I get the date right and not say it wrong like I did last time. 2038, yeah. So it is indeed. Timestamps go from 1970 to 2038. So that'll be another fun Y2KS thing when all of our timestamp columns in the next 15 years are all going to hit 2038, and we're all going to have issues with SQL databases crashing on our applications that are running out in the real world. But yeah, timestamps are a smaller, more efficient storage for things like our accounts being registered at a certain time. I probably use date times or even just dates for people's birthdays and things like that, because again, you could drop the time part and you can have just a date, year, month, day stored, and that'll be a great solution for something's birthday. But for an auto-generated column that's going to be definitely within this range, this smaller range for MySQL efficiency purposes, we'll stick with timestamp for this one. And we're going to say that it is going to have a default value. So this default keyword allows us to add a default value that will be inserted for this particular column value should one not be provided. So should we go and create a new date in code and insert it, it will use that. If we provide nothing for inserting a created at value, then it has a default fallback, like a redundancy, if you will. It's like, oh, you didn't give me a date? Well, it's okay. I have a default rule I follow to generate it. And we're going to have it's called the now function here in MySQL. You could also do current underscore timestamp. That's another flavor way. That's the same way of writing the same thing. I just think writing now parentheses looks cool. So yeah, we gave it a default value should one not be provided. And that looks like a pretty solid users table. So I'm actually going to go ahead and come down here and create this table. Bada bing. And now we're going to move down to the notes table and crank this one out as well. So what I'm going to do is copy this ID column code because, well, it's going to be the exact same thing. Same thing for the primary key. It's going to be the exact same thing. I'm going to copy the created at. So whenever a user creates a note, this will give me, and this does not have to be like tab indented and formatted nicely, but I'm trying to make it visually appealing for y'all. So that's why I'm actually taking the time to do that. Okay. Those two are a pretty sure bet that I'll always be generating an ID, a unique identifier for each row in this table, as well as some metadata about when it was written so I can organize them by newest to oldest, oldest to newest, find a range of a certain week or a certain month, etc. Just good stuff to have there, right? Something else that this is going to have to know is who wrote this note. And this is where we get into relational data in SQL, right, which is a relational database, in that we want to track who wrote this note. And you might be thinking, well, I'll store their email, maybe their first name or their last name or something like that. And that's fine, but it won't give you a lot of cool stuff that you could do without running a ton of additional queries. In MySQL, we have something called foreign keys. Unlike a primary key, which is an identifier for a particular row in this table, we can have foreign keys that point to an identifier in a different table. So I'm going to call this column user ID. It is also, and here's what's important about foreign keys. Foreign keys must match their primary key in the other table they're referencing. So our user ID column, clearly by its name, is going to reference the ID column in the users table, right? So this is the primary key in the users table. This is going to be our foreign key in the notes table, referencing back up to that other table. So these data types must match, otherwise this will not work. So I know my IDs up here are char36s, so this must be a direct match. You cannot have a note written by no one, so I'm going to mark them as not null. Okay. And we need to also mark this as a foreign key, which I will choose to do down here. I will say, hey, this table of notes has a foreign key. The column in this table is user ID, and it is a reference to which other table? The users table. And what column in that table? The ID column in that table. And there you go. Right, so you can write other keywords here, like our students might be used to seeing the words add constraint pop up and giving a constraint name like fk_users. Those are just like, you can almost like variable names. You can name your foreign key associations so you can manipulate them and identify them later down the line, but MySQL will auto-assign them a name, so there's no need at our skill level currently to add constraint names that we write ourselves. So I'm going to go ahead and leave it at that for our foreign key. So remember, this user ID column is now a foreign key that will point over to this ID. That way we can bring in the user's information via a join should we need to get that info about someone's individual notes, but we'll get there when we get there, right? Probably in the next video. Okay, so that's our users table. That's our notes table. Well, we actually need to have, right, what the note actually is. So I might call this the notes.text or notes body or something like that. Yeah, we'll call it notes body. And we're just going to do a varchar here, and we'll say like, I'll have a maximum of like 2,000 characters. That sounds pretty good for some notes right there. And I probably don't want accidental empty notes because that doesn't make sense, but we'll call that right there. Now, if you're wondering, should we have like a title or what session or what campaign it goes to when we get into more complex things, like maybe you are playing in 3 different campaigns and you'll want to know which campaign or which notes belong to which campaign. And yes, that's why I said that later we're going to flesh out some more of the database, but for now I want to get some just simple stuff up and running in order to get this project out of MySQL Workbench back into VS Code and talking about TypeScript, Node, Express, and back into Postman and whatnot. That's so as of right now, yeah, we just need to create these tables here. So I'm gonna go ahead and create them. I created now the notes table, so both are created. If I refresh the window here in MySQL Workbench, I can even see those 2 tables. So, okay, we got some stuff ready to go. Can we actually establish a connection with MySQL and what's it called? And get going here. But before we do that, I realize we actually have to create a user. So what do I mean by creating a user? You're like, well, Luke, don't I have a root user I could use? Yeah, you could technically use that in your local development, but that's, again, that's dangerous because that means that if someone got access to your root user, they can then mess with every single schema. I always tell my students that this is like the David Wallace of Dunder Mifflin, the root user. and you need to create a branch manager, such as Karen Filippelli or a Michael Scott, that can only rule over their branch or schema and not have access to the entire. You wouldn't want Michael Scott to have access to the entire Dunder Mifflin corporate structure. You would only want him to have managerial access to his individual branch right there. And so we need to create a user that has that scoped in authorization to make sure that if we have any kind of problems on our SQL server or breaches or whatnot, then that user that got hacked or breached cannot access other schemas worth of data. That way, that would be a huge mess up that we don't want to deal with, right? So this create user statement will, what's it called? It will have issues depending on which authentication plugin you're using. So if you're on like SQL 8.1 or higher, you can just write a simple create user statement and you have to use MySQL 2. If you're like me and somewhere on the 8.0 area, then you're going to have to create this with the old authentication standard to use the MySQL library. And if you have 5.6 installed, then you can get to write just a simple create user, right? So I think you do comments with hashtags, right? You do 5x, we got to talk about 8.1.x. And then for moi, we have a different one as well where it's 8.0.x or something like that. So those are our three different types we have to worry about. And depending on what you do, again, this is where you'll have to worry about how to write what we're about to write here. So the core statement, no matter what version you're on, is the following. We write create user. We give it a username. I'm going to just call it the same name as my schema, DnD note taker. At what host? In our case, it is localhost. That's what our host is going to be. And then we're going to write identified. Is it with or by? I can't remember. Normally, I actually point and click through this one. Yeah, it's with, not by. So it's identified with MySQL underscore native. Actually, we don't have to identified with. My bad. Create user, name of the user, at, and whatever the host is. In our case, it's localhost since we're doing, local. Our local host is our host. We're not deploying quite yet. It is identified, my bad, by, and this is the password we're going to use here. Now, I also write DnD note taker because again, y'all don't have access to my I'm not putting out my local MySQL server onto the web in any shape, way, or form, so y'all won't have access to this. But again, just make up a password. It doesn't really matter what it is for our little project here. You're probably, if you want to take this to production, make it a real project of some kind, then by all means come up with a better one than that. But you'll be given a different one in production anyway, so this won't actually affect anything in production. This is only for local development only. So that way, if you create or share your schema with other friends and have to use your code base and user, then you have to tell them what this password is. So if you're using just MySQL plain, then you could do the following and get away with it, no problem. You won't have to worry about anything, right? Now, if you're on 8.0.x like me, then in using the MySQL library for your connection, then you have to add a extra little clause here that says, hey, I know MySQL looks for the old auth standards and 8.0 doesn't use the old auth standards. So we can actually provide a clause between identified and by, where we specify we're going to be using the native password of MySQL's old auth versions. And that's what your new create user statement would look like. And if you're using MySQL 2, then I think you're fine just doing one of these right here, where if you're on 8.1 or higher and you have to use MySQL 2 because the authentication standards are just updated that way, then you're back to using the vanilla version right there. So this is a little just a decision tree if type situation going on here that you'll have to keep in mind. So again, because I'm using MySQL and I'm on 8.0, then you need to go ahead and run this command right here, and that creates the user. Cool, we can even take a look at that by going to the administrative tab and clicking on users and privs. And you see a test LOL test. You can see I do this a lot with students in webinars back in the day and video tutorials, but yeah, it should be, well, it's not there for some reason. No, it is. There it is. Yeah. Now we need to give this particular user privileges to run certain statements, right? So we want to make sure that this user at the moment needs to be able to run every privileges. I don't know how to spell it right. We need to make sure that this user can actually do stuff. Because otherwise we have a user that cannot run any kind of statements. For example, create tables, insert, update, deletes, and stuff like that. We want to make sure that this user is able to actually run our future commands. So we want, in this case, we're going to be making sure that they can run everything, right? Except for creating other users. Again, Michael Scott should not be able to create other branches and branch managers. He can hire as many people under him as is allowed by accounting and budget, but he is not allowed to go above his station and hire other branch managers and create other branches. That's what I mean by we're granting all, air quotes, privileges to our newly created user, DnD note taker. But the only thing that it can't do will be able to create other users, which is, that's where we got to make sure that we don't mess something up, right? So we need to write keyword grant all privileges. Is that how you spell it? Privileges? No, it's an I. It's an I, folks. There we go. That's what it is, right? Yeah, that sounds right. Hold on. Can I not spell this? I'm looking at Google to see. Yeah, it's okay. It's I-V-I-L-E. Okay, yeah. I totally knew that. Who said I didn't? Okay, so you're going to say grants all privileges on the name of the database, which will be DnD note taker. Note taker. I should have written down how to do this rather than think I could remember how to do it, but you know, it's classic me, right? To DnD note taker at local hosts, and that should be the command, right? And I think I need to specify that, because you can actually grant this user certain privileges on certain tables, but if I believe I provide a .*, that wildcard will specify all tables in the DnD note taker schema right there. So this is how you're going to grant all privileges that go along with our this is how you're going to make this user able to run commands on all tables. So like in production, in the real world, you'll probably have like a user meant for inserting, a user meant for reading. You can even create individual users for specific tables. Like maybe you want a different connection and user, specify with the users table, because that would make sense that you want something kind of isolated. That way, if they get, if they get like the notes user for the notes table, then that's not, that's okay. Not the end of the world. That's a lot of data that can get scraped. But if you keep like a separate user just for like your registered users table that manages the inserts and updates and deletes and whatnot, that gives you some like more level of control and just security to make sure that you can monitor that particular created user with its particular privileges for a particular table. So you can create users and grant them privileges on specific tables in your schema, but that's more of a big level application and production thing. We're just going to create one user that can do it all except create other users. Smack my finger on the microphone there. So grants all privileges. There we go. You don't have to do this as much these days from what I understand, but back in the old school, like older versions of MySQL, you would typically have to write flush privileges, which kind of is like a hitting your refresh key to make sure it's up to date and caught on there. So theoretically, we have now created a new user. We have given them the appropriate privileges on this particular schema, which means they can run all queries on all tables except for creating new users that are above them and have access to other schemas, which would be bad. And so we finally should be able to good to go back to our code. And this video is almost 40 minutes. That's okay. Let's get some kind of basic query up and running, and then we'll actually insert some data and test it in the next video. But for now, I do have this MySQL package already installed, so I can head to my server down yonder. And let's do some testing. So first things first, I want to import the MySQL library from the, MySQL library, and I now want to run, and I need to connect to MySQL somehow. So I'm going to write const pool. Now you can call this connection. I'm going to be teaching y'all how to do the following, which is called a MySQL pool, because when you do a singular create connection, you have to handle what's called the whole handshake process yourself, where you have to establish the connection, tell it what to run, and then end said connection, which is great. I mean, that's what you're probably going to be doing in larger scale projects where you manually have control over that stuff. In our case, we're going to be doing a connection that has an automated connect, run query, and end feature built in for us, and that's called a connection pool. And like the name implies, we can actually tell this connection pool how many specific connections we want happening at any given time. So we have a lot of customizability that goes along with it. So connection pools will require an object, just like create connections, that will have the following data inside of it. We're going to move this to environment variables here in a minute, but for now I want to make sure that this actually can establish a connection and run, well, any kind of query. We got to tell it what the host is going to be. That's our local host. What our user is going to be, I called it DnD note taker in our case. Same thing for the password, because that's the password I gave it, the same thing as its username. What database, so it says database, which I never liked this term, but it actually means the schema name, which is, surprise, DnD note taker. This is why I did it this way, to keep things simple. And then from there, you have a couple additional optional configurations, like you can specify your number of connection limits. Like, I think it defaults to 10 if you don't provide one, which is a solid number. You're probably not going to encounter issues with that unless you're not handling and resolving your promises correctly down the line. But I think a default of 10 is good to start with for our level of skill and project as of right now. So theoretically, that has created the pool. And there's some cool things we could do here, or we can just go ahead and test it. I mean, does it give us an error? Doesn't seem to. Again, my autosave is currently activated, hence why we see errors occurring up there, but your eyes just focus on the bottom part of the terminal to see a successful build. That's what we're paying attention to. We can test this sucker now to see if it actually connected and works by writing pool.query. We don't have any kind of data to insert or update, delete, or select yet, but we can run the following, which is a simple select statement that will ask it to run the following query, select 1 + 1, which should return to us a value of 2. As of right now, this won't run anything, as you see here, because, well, pool.query, the whole MySQL 2 libraries run off of the good old asynchronous way of handling code called callbacks. So our server, our Node Express server running right now, has to make that connection when it starts. Then when we tell it to run a query, it goes, got it, I'm going to take this query you gave me and run it over to the database. I'm going to run that query, get its results, and bring it back to you. Now, while it's almost instantaneous for our eyes, and probably in the real world until we get to huge data sets, that is still some non-zero amount of time that we have to account for, aka asynchronous code and not synchronous code. So in order to handle this issue, we have to provide what's called a callback function, aka this code in this set of curly braces runs after it either succeeds or it fails. To do so, we have to provide an error if one occurs, or our results should that not fail. And there's an optional third one we'll talk about later potentially. I never really use it though. But the first argument is going to be an error if there is one. So we'll say if there is an error, then console log what the error message is, so I can take a look at it like that. Does it not have an error message on there? Oh, because I called it error. Come on, Luke. Log what that error message is so I know what's going on. Otherwise, just go ahead and log the results as is so we can take a look at what we got here. So that's like pretty good little looking query right there. Let's go ahead and take a look at what happens when we go to our connection here. And as we see here, I did not get any kind of error. I actually got the results console log, which is 1 + 1, has a value of 2. That's awesome. Some things to note. If you're having an error right now that says, hey, your connection has been refused because of improper authentication protocol or something like that, that means you have to revisit what I told you about creating a user and how they're identified based on what library you're using and what version of MySQL server you're currently running, because that will dictate how these end up running here. So that's something that if you ran into connection refuse, authorization, or password not accepted or something like that, that's probably why. Google will be your friend. Hit us up in the comments as well for any kind of help you might need. But yeah, that pool has now ran successfully. and it ran that query. And let's take a look. Something important here is what it gave us. It gave us something called a row data packet, which is kind of like an array. It's not technically an array, but you can use array methods on it without too much issue. But this row data packet, look at its data structure, it's very important here. It is an array with an object inside of it, and that object shows us what the query was and what the value is here, right? So it's almost like the column name and the value name, because we didn't tell it what kind of column name to give it, which I think we could as some. That as keyword allows us to alias a column name right here. And yeah, see, so column value. And this structure, when you select things, any select statement in MySQL will give you a row data packet, an array of objects. Even if you're doing a where clause, select my first note only, it will still be an array of one singular object. It's always going to be an array of objects, whether it's one or many things it selects. That's the default data type in both MySQL and I believe MySQL too. So that's very important to keep in mind here. But let's crank it out. Let's go ahead and crank it out here, folks. One thing I'm going to go ahead and do is say our test is successful here, and we need to now convert this from just chilling in our server file to maybe, I don't know, into our database file. I'm gonna close out some of the old windows here. There we go. Let's go to database and make an index. Now we're gonna make a pool.ts, actually, not index. We're gonna make an index and a pool.ts. Now the index is gonna be just for import-export shenanigans, but the pool is we're gonna actually take and create and run this code right here. Let's cut it and paste it into my create pool. There we go. Now, from here, what we need to now do is head into our environment variables. So I'm going to head to my .env, and I need to create an environment variable 1, 2, 3, 4, db host, db user, db password, db schema for my environment variables here. So we're going to say db host equals localhost, db user equals DnD underscore note underscore taker. That's going to be copied and pasted a couple times here, because that's the same thing for my DB password. I'm going to forget I wrote pass instead of password. I know it. And our DB schema is the same thing. This is where you could also provide a DB connection limit and other things like that should you start customizing your pool connection here. So, all right, my environment variables are good to go, which means I now need to add this to our config object from way back in the day. So I'm going to head to the server config folder into the index file. All we have right now is our app port. I'm now going to include a new property, config.db, makes sense to me, which will be, well, let's just go ahead and copy this object here from create pool and paste it to our config object, like so. Make sure you don't have an extra set of curly braces. I actually replaced the ones I just written. And now I'm going to replace these with what they're appropriate. Process the environment variable, db host. I'm going to copy this part to the underscore, replace those three with it, and we'll do db user for this one, db pass for that one, and db schema for this one. And now we have our configured database object now coming from environment variables. I'm going to close out these files, because I should be good to go. And in place of this entire object, let's go ahead and import our config object from the config directory and simply tell it to use our config.db object, which should generate the correct pool, and now we can begin to test. So as of right now, even though I run this pool query, I'm not running that code. Like, there's no import reference to this pool file. So what I'm going to do is head to my server, and once again, I should just leave the testing comment here with how much we do this. We're going to say import the path to that file, db pool, and run the code within this file as a test. And let's see what happens. We got our row data packet, which means we are one step closer to glory. Okay, so yeah, let's do this here. I mean, there's nothing super wrong with dealing with callbacks and things like that. You could theoretically just export this pool and start writing queries left, right, and center directly in your endpoints. That's fine, but we're going to keep a layer of separation because I'm going to choose not to use an ORM or object relational management, object relational map tool, such as Sequelize to help generate a bunch of database code from Node and TypeScript. I like keeping the SQL kind of pure because if I have a friend that's actually he runs as a database admin here in where I live. And if I ever have issues with my database, I don't want to have to take the time to explain to him my TypeScript SQLized code that he may or may not know when I need help with optimizing a database. So, it really depends on the project size. If I was in a hackathon, I would pick up an ORM or even like a query builder like Knex, Knex is a great one to look into if y'all want to take a look at that library. But if I was in building something for clients on a tight deadline and a hackathon or something like that, I would, or a team that happens to know a specific ORM, I would go and use one because that's what it would just make sense to me. We're going to keep writing everything by hand, so if we have a buddy that's really good at SQL, they can come take a look at all of our SQL code and actually give us a hand without having to learn that ORM in the process. So we're going to have to take more time to write it, but we'll learn more in the process. It'll give us a more fine-tuned control. And, again, if you have learned more and more about database stuff, you won't have to be fighting against the ORM to do advanced database queries, so you start learning how to do them. So that's what we're doing here. So I'm not going to stick to using the callback structure, so I want to actually abstract this one layer out, and we're going to write the following: export const query, like that. And what const query is going to do is it's going to be a wrapping function around our callback that allows us to run a promise instead. So we're going to comment this out for now and call this old busted. And let's see what happens when we do the following. We're going to create a new promise that will be created when this function runs. This promise takes a callback that provides us with a resolver function and a rejecting function. And what I would like for it to do is to run the exact same code I had a moment ago, which means I should probably just go and copy and paste. Comment that back in, copy the code, comment it back out. That's Control/Command/ on Mac. Paste that code in. And instead of simply console logging what the error is, I'm going to ask it to stop the query and reject. I can't remember if reject automatically returns or not. Well, we could always just return whatever the reject happens to be. There we go. Just want to make sure it stops in its tracks right there. What the reject with our error right there, and instead of just console logging the results, I would like you to resolve with the results instead. Okay, so now that we have this function written, remember this is what old busted looked like. That's what we have to write for every single query. We'll call this the new hotness example. And this new hotness will be, hey query, run select 1 + 1 as sum. Oh, I forgot to provide an argument, right? Well, first off, I realized that the pull query already has that written here, so let's take a step back. Let's take a step back, folks. New hotness, run that select query. Then when it resolves, grab me them results and log them. If it happens to error, catch it and log what that error.message happens to be. And there we go. That is the new hotness. That way, when we have to run our queries, we no longer have to write and deal with callback hell should we have one query run another, run another, run another. We can now just daisy chain them as promises, and our lives are going to be much cleaner and easier for it in the long run. As you can see, it still works the same way without any kind of issue. We're going to take this one step further, folks. Clearly, this is not the query I want to run every single time, so I will say, how about I need to provide the SQL for it, and we're going to copy that. We'll call it the SQL. It'll be SQL. It'll always be a string value that we pass in, and that's what it's going to be right there. So now our new hotness can now take a custom query. Let's change it up, 1 + 3. Hey, that's what I'm talking about. Now we can pass any custom query, select, insert, update, and delete statements to this query utility function, and then promisify and make our lives cleaner and easier for it. That's what I'm talking about, y'all. Other things you can actually do here, there's going to be some cool tricks we can do. For now, I'm going to call that any, because when you run insert, update, and delete statements, you can actually provide dynamic values for it to insert and update, for example. So there's actually some really cool things you could do. So yeah, what I'm actually going to do as well right here is call this the query. MySQL has a format function that can take our SQL string. Oh, no, undo. Our SQL string and values and output. Yeah, I shouldn't call this lowercase query. That's going to be kind of confusing. We'll call it formatted, or like our prepared statements, right? What it's going to do is it's going to take our SQL string any dynamic values we have on them and generate your formatted and sanitized, which we'll talk about in definitely the next video, since this video is almost an hour long. Takes those values and the SQL statement and creates the prepared statement to run in our pool.query. So rather than running the SQL directly, we're going to run formatted. What does this do for us? It also allows us to console log the formatted statement to see what it ends up looking like if we're curious about it. So for example, oh yeah, there is the prepared statement that it ran for us. So as of right now, I'm not passing it any values. And don't forget, I use a cool little trick here in TypeScript that gave me this question mark that dictates to TypeScript this is an optional argument that can be passed to this function or may not be passed to the function. It doesn't really matter. Again, we'll talk about what you can do with this in a future video, but I like doing this a lot and helps me debug my SQL statement should one be going wrong. But for right now, I'm going to go ahead and nuke that because I don't need that console log at the moment. This is what our query utility function is going to look like. You notice here it's being exported, not by, I chose to export it by its individual name. You can do a default export because it's the only thing we'll have from this file. But as of right now, looks like we are good to go. So at the end of this video, let's see what we need to do here. That's all fine and dandy. We're going to pick up with this in the next video where I actually start inserting data and stuff like that and dealing with authentication and creating users, blah, blah, blah. Back to our server, remove this testing code. And I told y'all, oh yeah, I'll give y'all a copy of this schema. So I'm going to copy it here and come down here and maybe we'll call it the, I don't know, schema.mysql, even though it's just a text file, who cares what it is? There we go. This should just be a text file, so I might just call it schema.txt or something like that. There we go. Yeah, so we have our text file here. If it happens to have a different name, I don't think there's an extension that I can deal with here that'll actually help it. That's fine. Doesn't really matter what it is, what we call it. It's just a text file. Y'all can look at the schema right here that we all can take and carry along with what I've done here in the video as well, if you're not nearly as versed in SQL as I or some of my students might be. But yeah, let's see. I think that about wraps up in the video. So we're at a pretty solid stopping point here. I'll push this to GitHub because I forgot the end of the last video. Sorry for folks that were looking for it. Ending part 3. Yeah. And we'll push that on up. Cool. And yeah, so make sure y'all like, comment, and subscribe. Stay tuned for part 4 where we pick up where we left off. Check the description below for links to the previous video, links to this repo, and links to the playlist, as well as links to our website and things like that where you can get involved in our community Discord and whatnot. And yeah, I'll see y'all in the next video where we pick up where I left off and talk more about queries and databases and inserting data and authentication and creating users. Oh my, this is so much work. But it's fun, right? We're learning here, folks. Ta-ta.